So the second half of our unit with implicit differentiation is going to be applying the process of implicit differentiation to word problems. But when we set up these word problems, we're going to find the derivative of every variable with respect to time. So you can see I added that here to our notes. So if we have a problem about area of a circle, every single variable we're going to take the derivative of with respect to time. So for example, when we were doing normal derivatives with y, we did the derivative of y with respect to x. So now the way everything is going to work is the derivative of area with respect to time. The denominator will be with respect to time. Here I have some other examples written. The derivative of x with respect to time. The derivative of y with respect to time. V for volume, the derivative of volume with respect to time. So that derivative, that rate of change over time, will be something like feet per second, or inches per minute, or miles per hour. We're always going to have that time aspect of these word problems. So we're going to do problems 1, 2, and 3 together in the video. Your homework, I'm going to modify a little bit when we get towards the end of the flip chart. I'm going to eliminate some of the problems. Okay, so for number 1, I'm going to read it once and then piece together what we need. A spherical balloon is being inflated at a rate of 10 pi cubic feet per second. At what rate is the radius increasing when the radius is 2 feet? So first off, we have a sphere. So the volume of a sphere is 4/3 pi r cubed. On your test, we will give you that formula so that you do not have to memorize the different geometric equations again. So now all the pieces that they give us, at this rate of 10 pi cubic feet per second, that's a volume rate. So that's going to be our dv dt. The question is, at what rate is the radius increasing? So that's going to be dr dt. That's what we have to find. And then we're also given the radius is 2. Okay, so our first step with using this volume equation is going to be to take the derivative of every variable with respect to time. So every variable that I take the derivative of, I'm going to have that derivative over time. So the v changes to v dt. Now for the 4/3 pi r cubed, 4/3 pi is a number, it's a constant. So I'm going to do the normal power rule where the 3 comes down, reduce the power by 1, but then because we dealt with a variable, we need to include dr dt. Now we're going to plug in all of the different values that were given. dv dt here is 10 pi. And then they give us the radius is 2. So now we can simplify, and we're going to solve for dr dt. So 2 squared, that's 4, times 4 is 16 pi. And then I'm going to divide both sides by 16 pi. And if you type that in your calculator, the pi's will cancel each other out. 10 divided by 16 is 0.625, but we need units. So if I look back at the problem, it is feet per second from here as a rate. So our answer is 0.625 feet per second. Okay, so number 2, a ladder 25 feet long is leaning against a wall. Let me draw that. So here's our ladder, which is 25 feet. If the foot of the ladder is being moved away from the bottom of the wall at a rate of 14 feet per second, what rate is the top moving when it is 7 feet above the ground? Okay, so let's put some variables in so we can talk about this triangle. I'm going to call the base x and we'll call the height y. So if we were going to relate all of these variables with the ladder, we're going to use Pythagorean theorem. X squared plus y squared is 25 squared. So now, what other information are we given? The bottom of the ladder is being pulled away at a rate of 14 feet. So that's dx dt is 14 feet per second. We want the rate that the top is moving down. So dy dt, that rate is what we're going to solve for. And we get that the ladder is 7 feet above the ground. So that means that y is 7. Well, we can use Pythagorean theorem to find out what the x side is, because we probably are going to need that value once we take the derivative. So if we do Pythagorean theorem with the x, 7, and 25, we're going to solve this equation for x, and we're going to get 24. Okay, so now let's take the derivative of our equation here. Every variable is going to get that derivative with respect to time. And then 25 squared is a constant, so the derivative of that is 0. So now let's see, what do we have that we can substitute our values in? X is 24. Dx dt is 14, y is 7. I don't know dy dt, that's what we have to solve for. Okay, so now we have a bunch of arithmetic. If we multiply these numbers together, that's 672. 2 times 7. Okay, so I'm going to move the 672 to the right. Divide by 14. So dy dt is negative 48, and our units are feet per second. So the negative value is just telling me that it's going down. It's going in the opposite direction. So because I considered the bottom to be moving at a positive direction to the right, the y is moving down, which is the negative value as an answer. Okay, so now number 3. At a given moment, a car is 30 miles north of an intersection, traveling towards the intersection at 45 miles per hour. At the same time, a truck is 40 miles to the east. Okay, so let me start drawing this. If this is my intersection, my car is north and my truck is east. The car is 30 miles north. The truck is 40 miles east. And I'm going to call this side C and this side T. And then I'll just call this side H for hypotenuse. Okay, so we use the 30. We use the 40. So the car is traveling at 45 miles per hour. So dc dt is 45. But because it's traveling towards the intersection, and the way I drew my picture, I'm going to make that the negative value because it's going down or in going south in direction. The truck, so dt Oh, that's annoying. You know what? I'm going to call truck K because I can't have two T's. All right, so this is the truck. So I'm going to call that K. So dk dt is 35. Is the distance between the vehicles increasing or decreasing? So what we need to find, and at what rate, so this is h, the distance, and the rate is dh dt. Well, we can find h by using the Pythagorean theorem. 30, 40, so actually it's a 3, 4, 5 triangle, so that's going to be 50. And if I relate my variables, c squared plus k squared equals h squared. And the reason I'm going to leave this as a variable now as compared to number 2, we want the rate of h. So I need an dh dt in my equation once I take the derivative. So this is going to give me 2c dc dt plus 2k dk dt equals 2h dh dt. Because everything has a 2, I'm going to divide the whole equation divided by 2. And that's going to leave us with c dc dt plus k dk dt equals h dh dt. So now I'm going to plug in all the numbers that we already have. So c is 30, dc dt is negative 45, k is 40, dk is 35, h is 50, and we need dh dt. So now, getting all my values, if I multiply these numbers, it's negative 1,350. Multiplying these, it's 1,400. And now we can add those together and get 50 on the left side of our equation. And we're going to divide by 50 to isolate our dh dt. We get 1 is dh dt, and it's miles per hour from the units in the problem. So because it's positive, it's getting further away. So what we found is the rate of this, the distance between the vehicles is increasing. It's positive, which means the truck is getting further away from the car. We're going to skip number 4. So in your packet, the homework is the related rates problems number 1 page, but only do problems 1, 4, 5, and 6. And I will answer those questions the next time I see you in class, and then we will go on to the second day of related rates.